Right now, in the United States, over 46,000 bridges are classified as structurally deficient. That's roughly 7% of every bridge in the country. Nearly half of all 623,000 bridges are rated quote, _0 _, which means aging, declining, and on a trajectory toward deficient if nothing changes. The average American bridge is approaching 50 years old. The standard design lifespan for a bridge is 50 years. You probably drove over one this week. Statistically, you probably drove over several. Last video, buildings that collapsed because someone ignored the warnings. Seoul, Genoa, Bangladesh, Surfside. The pattern was the same every time. Report filed, warning delivered, doors kept open. Today, part 2. The buildings and bridges that haven't collapsed yet. The ones with reports on file, repair budgets sitting in committee, and people inside right now. August 1st, 2007, 6:05 p.m., rush hour. The I-35W bridge in Minneapolis, an 8-lane steel truss bridge carrying 140,000 vehicles per day across the Mississippi River, collapsed without warning. The center span dropped 108 feet into the river. 111 vehicles went down with it. 13 people died. 145 were injured. The bridge was 40 years old. It had been inspected regularly since 1990 and was classified as structurally deficient due to corrosion and cracking in the cross girders. But none of that caused the collapse. What caused the collapse was a set of steel connector plates, gusset plates, that held the truss members together at a critical node. They were half an inch thick. They should have been 1 inch thick. That error was made in 1961 during the original design by the engineering firms Sverdrup and Parcel. It was never caught, not during the design review, not during construction, not during 40 years of inspections. For 4 decades, 140,000 vehicles drove over a bridge every day that was held together by steel plates half the thickness required by its own load calculations. Nobody checked. Not because the technology didn't exist, because gusset plates weren't included in standard load rating procedures. Inspectors weren't trained to look for them. The system assumed they were fine, so the system never asked. On the day of the collapse, construction workers had placed 262 tons of equipment and materials on the bridge deck, sand, gravel, machinery, directly above the weakest gusset plates. The plates, already operating at near their yield limit under normal traffic, fractured. The bridge had no redundancy. Once the plates failed, the entire truss followed in seconds. After the collapse, the Federal Highway Administration told states to inspect the 700 bridges of similar construction across the country. Several had the same gusset plate deficiency. The NTSB's final report concluded that the probable cause was a design error from 1961 combined with 40 years of inadequate inspection protocols. A half inch of steel, that was the margin. The I-35W collapse was supposed to be a turning point, and in some ways it was. Inspection standards were updated, gusset plates were added to load rating protocols, and Congress passed emergency funding. But the broader problem didn't go away. It got a report card instead. Every 4 years, the American Society of Civil Engineers grades the country's infrastructure. In 2025, the overall grade was a C. That's the best score since 1998, when they started giving grades. The improvement came partly from the 2021 Infrastructure Investment and Jobs Act, which pumped over $40 billion into bridge programs alone. Bridges specifically got a C, up from a C-. Sounds like progress. Here's the context. 46,000 bridges are still structurally deficient. 42% of all bridges are over 50 years old. The estimated cost to bring every bridge to a state of good repair is $373 billion over the next decade. The current funding trajectory covers roughly 2/3 of that. The gap, the difference between what's needed and what's funded, is over $100 billion. And bridges are one of the better categories. Roads got a D+, schools got a D+, stormwater got a D, transit got a D. A structurally deficient bridge is not the same as an unsafe bridge, technically. It means the bridge has been inspected, rated, and found to have significant deterioration that requires monitoring or repair. It does not mean the bridge will collapse tomorrow, but it means the bridge is on a list, and the list is long, and the repairs move slower than the deterioration. In January 2022, the Fern Hollow Bridge in Pittsburgh collapsed while a city bus was crossing it. 10 people were injured, including the bus driver, who was pulled from the wreckage by first responders rappelling down the ravine. The bridge had been inspected repeatedly. Problems had been documented. The National Transportation Safety Board concluded that critical lapses in maintenance and oversight by multiple agencies led to the failure. Inspectors had identified issues. Repairs were not performed. The Fern Hollow Bridge was not on a secret list. It was on the regular list, the same list as the other 46,000. This is not an American problem. After the Morandi Bridge collapse in Genoa, Italy launched an emergency audit of its bridge infrastructure. The results were bleak. Hundreds of bridges flagged for urgent repair, decades of deferred maintenance uncovered, and a national reckoning with the cost of privatizing infrastructure oversight without maintaining accountability. France conducted a similar assessment in 2019 and found that roughly a third of its bridges required repairs. Germany identified thousands of bridges built during the post-war construction boom that are now past their design lifespans and carrying traffic loads several times higher than they were designed for. The pattern is global. Countries build infrastructure during periods of economic expansion. The infrastructure ages, the maintenance budgets don't keep pace, and the gap between the report and the repair widens until something falls. The pattern from last video, report, warning, inaction, didn't stop at buildings that already fell. It's the operating procedure for the ones still standing. Here's the number that stays with you. The ASCE estimates that for every dollar invested in infrastructure, the economy sees a return of roughly $2.20. The cost of not investing is higher. The 2024 Bridging the Gap report calculates that the total investment needed over the next decade is $9.1 trillion. The current trajectory covers $5.4 trillion. The gap is $3.7 trillion. That gap is not abstract. It's 46,000 bridges with documented deficiencies. It's roads that cost the average driver $1,400 a year in damage and delays. It's school buildings where the infrastructure grade is a D+, and 56 million students show up every morning. It's over 22,000 bridges that are specifically flagged as susceptible to extreme weather events, storms, floods, temperature shifts, in a decade that has produced $27 billion weather disasters in a single year. The thing about infrastructure is that it fails quietly until it doesn't. A bridge doesn't collapse because one crack appeared yesterday. It collapses because 1,000 small decisions, to defer maintenance, to underfund the budget, to assume the inspection report will be acted on by someone else, accumulate over decades until the margin runs out.
The I-35W bridge didn't fail because a half-inch of steel was missing. It failed because for 40 years, nobody measured the steel that was there. The science of building is not the problem. We know how to build bridges that last a century. We know how to inspect them. We know how to fix them. We've known since 1961 that a half-inch of steel can be the difference between a bridge that holds and one that doesn't. The problem is the same one it was in Seoul, in Genoa, in Savar, in Surfside, in Minneapolis. The distance between the report and the repair. That distance is where the failures live, and right now, that distance is measured in trillions. Buildings fall because someone cut a corner. What's underwater? Nobody even checks.